Today we solved equations that have x on both sides of the equal sign. So in order to solve these, your first step is to get rid of all the x's off one side. Now this side has 9 x's, this side has 3 x's, so we're going to get rid of all the x's over here. So what I'm going to do is I'm going to subtract 3x from this side, but what I do to one side I have to do to the other. So subtract 3x off that side. Now, these 3 x's all undo each other because we just got rid of them. But 9 x's take away 3 x's leaves me with 6 x's. The plus 7 drops down, the equals drops down, and the 25 drops down. Now we have an equation we know how to solve because we've been solving those since last week. So we have to undo the plus 7, so we're going to subtract 7, but what we do to one side we have to do to the other. Adding and subtracting 7 undo each other. 6x drops down, equals drops down. 25 take away 7 is 18. And now our last step. It says x times 6, so we're going to undo multiplying by 6 by dividing by 6. But what I do to one side I have to do to the other. So multiplying and dividing by 6 undo each other. So the x drops down, the equals drops down, and 18 divided by 6 is 3, and that is my answer for x. Now, if I wanted to check to make sure that truly is my answer, all I have to do is take my x value, 3, and put it back into the original equation. But notice, there are 2 places I'm going to have to put 3. See, I have an x here and an x here. So when I check my answer, I'm going to have to put 3 right there and here. So instead of doing 9 times x plus 7, I'll do 9 times 3 plus 7. And that should equal, instead of 3 times x plus 25, we're going to do 3 times 3 plus 25. If those 2 things really are equal, then we know x must be 3. 9 times 3 is 27, plus 7, that's 34. 3 times 3 is 9, plus 25, that's 34. They're equal. Our answer must be 3. And that is how you solve an algebra equation with x on both sides.